right, I'm back for the last lesson. Sorry guys, I'm teaching this all in one day, so if I'm a little foggy, I apologize because I know I've been mixing my words a little bit. All right, so thymus gland. The thymus gland functions in childhood to make T4 cells, which are a special type of white blood cell that functions in immunity, okay? So the thymus gland works in your childhood. So this is where I said to you, many of you guys are going to be losing that thymus gland now. They make T4 cells. T4 cells, you probably know, are associated with AIDS, okay? And then thing on COVID-19, I just thought I'd let you know. I was very curious when this first happened in March. Why is COVID-19 attacking the elderly? Why does it have such an effect on the elderly? And it's not so much that it's attacking the elderly. Just a little aside here, because I thought about giving you this as a question, but I'm not going to, because you guys have enough on your plates. What happens is that when elderly people get COVID-19, and I know this is a general statement because young people can get very sick as well, but what happens is these T4 cells become very active, and they trigger something called the cytokine, okay? And this happens to everybody as they get older. This is why you have a harder time fighting infection as you get older. So T4 cells trigger cytokines, and what happens is that cytokines react to any kind of an infection by causing inflammation. So inflammation, again, I told you, is our protective mechanism. But when your heart starts to get inflamed because you're infected, that's not going to help you. And so why are the elderly dying from COVID-19? Because they have less of an immune system, okay? So what happens is when you have less white blood cells, your body panics and says, okay, I don't have the white blood cells I used to, and it releases these cytokines. And it's called the cytokine storm. So I heard that word in the news and I thought, what the heck is that? And I looked it up. So a cytokine storm means when you're older, you release a whole bunch of cytokines in order to compensate for the fact that you have less white blood cells. And the cytokines create inflammation. And so that inflammation is really fatal when it's in your lungs and when it's in your heart. So this is why the elderly even get pneumonia or any kind of like something that you and I could fight, like influenza. They don't do so well. And it's because of this. It's the compensation of the cytokine storm because they don't have enough immune system anymore. All right. So just a little aside there, bringing into day-to-day life with this COVID-19 crisis that we're going through. All right. What's important for you to know? After puberty, your thymus gland begins to shrink. Okay. And basically it just becomes this fat mass, a mass of fatty tissue that doesn't serve any purpose anymore, okay? So you make lots and lots of white blood cells in childhood, and then those guys are going to reproduce through mitosis for the rest of your life, okay? And of course, obviously, because of telomeres, et cetera, we're going to make less and less viable cells, and so you get less white blood cells. You get less of an immune system as you get older. All right, the adrenal glands. So you have two adrenal glands, right? One on each of your kidneys. Here's the place where we can color code a little bit. The cortex is the outside of the adrenal gland, okay? And it'll be the outside of the brain when we get to that as well. And the medulla means middle, okay? So the middle of the gland, the interior of the gland, is called the medulla. So that's the medulla, and this is the cortex, all right? So you in your adrenal glands have your medulla, which makes certain glands, and the cortex makes others. So let's deal with epinephrine or adrenaline and norepinephrine or noradrenaline, okay? So again, epinephrine and adrenaline are the exact same hormone. Norepinephrine and noradrenaline are the exact same hormone, two different names for the same thing. Where are they made? In the medulla, okay? So the orange section, so I should have highlighted that in orange. They act as neurotransmitters. So we're going to spend a couple days on neurotransmitters as we move through this unit. Neurotransmitters, they're chemicals that are released from a nerve cell, so your neurons are going to make them, and they're going to help amplify the message sent by your nerves. Okay, so that's all you need to know at this point. We're going to get into detail with these guys with calcium and other types of results. Okay, so these guys are released in the bloodstream and are involved in the fight or flight alarm response. So you probably know yourself. If you've ever been really frightened, you will know what your personal response is, okay? So typically there's a fight or flight. Now, you might see this, you can look it up on YouTube, but it is kind of humorous. Some people that get scared will punch immediately. And it's not because they're vicious, testosterone-filled people. It's because that's their natural response. So some of us are wired differently, right? Different response due to stress. You have to remember we had lots of predators before we built our nice, cozy homes. And this is left over from our evolution. So some people will fight their predator. They will try and survive that way. And some people sort of fight first, and some people will run, okay? And if you know your response. And some people will just stay in one spot and try and hide. That's another response that's not on here. But when it's involved with adrenaline, you're going to fight the predator, or you're going to run as fast as you can from the predator, okay? And that's a result of adrenaline. So adrenaline is secreted when the body encounters stresses like emotional excitement. So excitement is a stress. Even if you're extremely happy, Christmas Eve, okay, you can't get children to sleep. That is actually, even joy is considered a stress on the body because you're releasing a lot of adrenaline. So it's released in response to an emotional excitement into danger for sure. Okay, you've heard stories about people lifting things that are way too heavy to lift, and that's because adrenaline is really feeding that muscle and you can do amazing things with it. Anger will cause adrenaline. Okay, you'll have an adrenaline rush. Fear, all right. Infection causes the onset of adrenaline, injury, even anxiety. Okay. So those of you that are lifeguards know that injury will cause shock, and that's a result of adrenaline surging through you as well. So these hormones have target cells throughout the body. So lots and lots of your cells have targets or are target cells for this and have receptors. So they cause increased heart rate, all right? When you have adrenaline, your heart rate's going to go up. Why? Because you have to fight or flight. You're going to increase your blood pressure. You're going to release sugar. Why? Because your body needs sugar. It needs energy to increase its fight or flight response. If you've got a grizzly bear chasing you, not the best response. I think that you have to fight the grizzly bear or stay still. But let's say you decide you're going to pick up and run. You need a lot of sugar in those muscle cells, okay? You're going to have dilated pupils so that you can focus in, tunnel vision, all right? And you're going to increase that metabolic rate, which I just mentioned. So releasing sugar will increase your metabolic rate because you need lots of nutrients to get to those cells so that you can run or fight, all right? So basically, what are you doing? You're preparing your body for vigorous activity. Epinephrine is given to a person that might have a severe allergic reaction. So think about this now. This is the EpiPen. I don't have that written down there. But the EpiPen causes you to increase your blood pressure, EpiPen, and it opens airways, okay? So the EpiPen uses epinephrine to open the airways. So if you have a severe peanut allergy, you take epinephrine and it works extremely quickly to get the job done, all right? And so we've got stress hormones here. I just thought I'd put that there. You can take a look at that and see what the different responses to adrenaline are. Aldosterone is involved in osmoregulation. Okay, what's osmoregulation? It's the regulation of your water balance. Okay, so osmoregulation involves water balance. I'm going over that quickly because when we get to osmoregulation in the kidney, we're going to have time to talk about that. So osmoregulation influences your blood pressure, okay, and it targets nephron tubules. So your nephron tubules are in your kidney. All right, so we don't say that we have kidney cells. We have a whole bunch of kidney cells that make up these functional units called nephrons. All right, so that's found in the kidney. What aldosterone does is it increases sodium absorption. So if it increases sodium absorption, in order to dilute our sodium, we hang on to extra water, and that's how it's involved in osmoregulation and maintaining your water balance. Okay. So if we're going to absorb something, that means we're going to keep it. If we keep extra salt, water will follow to dilute it, and so we end up retaining extra water. All right, and again, we'll look at that with the nephrons next week sometime. Okay, so then we move on to cortisol, another stress hormone. All right, so cortisol regulates your blood glucose level. So you can see you've got quite a few things regulating blood glucose levels. You don't just have one hormone that's in charge of that, and that's because blood glucose levels they're essential to your moment-to-moment life. If you don't have blood glucose, if you don't have a high enough level of blood glucose, you're going to shut down. Okay, the first thing you're going to do is start to lose your vision. Your hearing's going to start to go, and you're going to pass out because the optic nerve uses so much ATP, if it's not going through cellular respiration, if your body's not going through cellular respiration quickly enough because it's not getting enough glucose, you're going to pass out, all right? And then other things are going to shut down if that doesn't fix itself. So what cortisol does is it promotes the breakdown of fats and proteins when glucose is low, all right? So it recognizes low blood glucose levels, and it's going to turn to something that's going to offer it some energy if there's not enough glucose, okay? And that's why you shut down and you pass out for a little bit so your body can get control over this. So it helps you to deal with stressful situations within minutes, all right? So an example is physical trauma, surgery, and exercise. So if you over-exercise, sometimes you feel like you can pass out. That's the reason, because you're producing lots of cortisol, and cortisol is saying, okay, I need to break down fat and protein because you're low on blood glucose. During some surgeries, they will put cortisol in a drip. I read that to help your body to deal with the surgery. Okay, so in that drip, the IV drip, sometimes the doctors will put in, or the anesthesiologist, somebody will administer some cortisol to the body so that I can deal with stress. If you have a lot of anxiety, depression, and you have a fear of crowding, you release cortisol when that happens. Okay, so just a little bit of information on that. Cortisol is involved in each of these feelings. And if you decide you're going to fast, okay, when you have a fever and when you have an infection, cortisol is also released to tell the body that it has a stress, some kind of a stress acting. Okay, we're moving on to the last two glands here, all right? So we've got the pineal gland, all right? The pineal gland is right here in the brain, all right? And it receives information. This is the front of the head. It receives information via the optic nerve. So the optic nerve obviously doesn't stretch outside of your body, but it does receive information from the optic nerve. So keep that in mind, all right? The hormone that it secretes, the pineal gland secretes, is melatonin, all right? So melatonin helps you to regulate your circadian rhythm or your biological rhythm. So it works with your retina's visual input. So what does your retina register? It registers light. And so when you see light, you don't secrete melatonin, okay? So in other words, during the day, you wake up, there's light, so the sunlight hits your I can't think anymore, your eyelids, and that triggers your optic nerve, and your body says, okay, there's light, I'm not going to produce melatonin, and so you wake up. And then you live your day, hopefully, out with seeing, I can't speak today, obviously you guys can figure that out, with the sun's energy, and you can see light everywhere. And then let's say it's winter, and the sun's setting around 4:30. So as soon as that sun sets, your brain starts to realize that the optic nerve is not receiving a lot of light, not lots of sunlight, and your house tends to be darker in the winter, even the lights can't compensate for the lack of sunlight. And you start to release melatonin. So in the winter, we have less energy and we get tired more frequently. And it's also related to vitamin D and a whole bunch of things. But this is just one example of why that happens, okay? So as soon as you stop seeing light, your brain starts to increase melatonin production. So melatonin is secreted mostly in periods of darkness, okay? And so because of that, you have a wake schedule and a sleeping schedule. Now, many of you, even just looking at my LMS class list, I can tell when you've logged in and when you haven't. And you're doing the same thing my teenagers are doing. You're sleeping till at least noon, okay? And then you're staying up till all hours of the night. And that's because, and this is a lot of result of technology, it's the fact that you're looking at your screens, okay? So you're going to hear it from your parents and you're going to hear it from me. You shouldn't be looking at your screens at least an hour before you want to go to sleep, because what those screens are doing is they're producing light. And whenever we watch television, okay, and I know that's not really what you're doing, you're really looking at your phones. If you're watching YouTube videos or whatnot, that is signaling, it's all the way that you receive that information is through light. And so what's happening is that you're getting lots and lots of light stimulation to your optic nerve, and your pineal gland is getting stimulated by light. And I know I kind of said the opposite before, you know, when it's dark and you're not getting compensated, but you're getting flashes of light from your phones. And that's telling your body that you're not ready to sleep. And so the longer you keep that phone on and that screen on, the less melatonin you're producing. And so it's really messing up your sleep schedules, okay? So if you want to get back to your sleep schedule, get off your phone so late at night. All right, and that'll help you because eventually we're going to go back to normal and you guys are going to have to go back to school and you're going to have some jobs. Maybe you'll get back to your summer job this summer, who knows? And so that's just my little piece of advice for you. Don't be on your phone, don't be on the screen as long, okay? Let your brain absorb the darkness and then you will make melatonin and you'll be told to sleep. So, sorry, made a short story very long. Jet lag is due to that as well, okay? So when you go off to someplace else and you realize the sun is setting 3 hours later, but you're kind of getting tired, or the vice versa is even worse, okay? That the sun is not setting and you are feeling really, really tired. I think I just said the exact same thing. That's because your brain needs 3 days to synchronize the sunlight with the pineal gland and melatonin, okay? So that's what we call jet lag, all right? And even when we switch the clocks back in in March and in October, right after Halloween, we switch our clocks back. That 1 little hour difference does make a difference because we're seeing the sun set at a different time and rise at a different time. All right, sorry to make that so long. The pancreas, we're going to look at another antagonistic pair of hormones here, okay? So the pancreas is in charge of your blood sugar levels, okay? And it secretes insulin. And what does it secrete it from? These beta cells. Okay, so if we were to look at the pancreas, you would see the islets of Langerhans and there are beta cells there. What do beta cells do? They lower blood glucose levels. Okay, and I'm going to let you just read through that because I'd like to show you on the diagram, but your information is here. So the pancreas makes insulin, okay, and it also makes glucagon. Now, glucagon is different than glycogen. Glucagon is made by alpha cells, okay? And if it was the past and you'd have to write this on a test, I'd say there's an A in alpha, there's an A in glucagon, or alpha starts with A, and that's how I think of it, okay? Alpha starts with A, and there's an A in glucagon. There's no A in insulin. So alpha cells are in charge of making glucagon. What does glucagon do? It increases blood glucose, okay? So when we look at this diagram here, and then I'll give you a little flow chart. Glucagon and insulin are called antagonistic pairs of hormones because they work to create a perfect blood sugar balance in your body, okay? So if we have, I'm just going to take it from the top here, the top feedback loop. So this would be homeostasis in the center. This is a negative feedback loop, and this is a negative feedback loop, okay? So if we have low blood levels, low blood glucose levels, okay? So if blood glucose levels are low blood glucose, what happens is the pancreas secretes glucagon, okay? So the alpha cells in the pancreas secrete glucagon. What does glucagon do? It takes our stored glycogen. Now remember we talked about glycogen in the very first unit. It takes our stored glycogen and breaks it down into glucose, okay? So this is dark here, all right? So it takes glycogen and breaks it down into glucose, all right? And then what that does is it raises your blood glucose levels, okay, to the point where you need it to be raised. Now let's say you have a huge meal and your blood glucose levels are soaring. At that point, you want to lower blood glucose levels. So what happens then is the pancreas secretes through the beta cells, it secretes insulin, okay? And insulin does this, okay? So insulin does the opposite. It takes glucose, extra glucose, and it makes glycogen, all right? And in doing so, the liver absorbs the extra glucose, and you get glycogen, and glycogen is there for a rainy day when you need to make more glucose, all right? And what that does is it lowers blood sugar, okay? So these guys are antagonistic, all right? So I'm not going to take too much longer here. I'm just going to help you out just a little bit with a flow chart, and then we're done. So if your blood glucose levels, if your blood sugar levels or blood glucose, I'll say blood sugar levels, are low, what's going to happen? You're going to increase glucagon, okay? You need to do that. So you're going to increase glucagon, and that's going to be via the alpha cells of the pancreas, okay? So the pancreas has alpha cells and beta cells. And so once you increase glucagon, what you're going to do is convert glycogen into glucose. Okay, and so you're going to increase your blood glucose levels. All right, and so that if you want to put a little arrow there, you can say that, but I'm just going to say that you've increased glycogen to or you've increased your glucose levels. Now, keep in mind, glycogen is a temporary storage in the liver used for extra glucose. If you have tons of glycogen, then you start to make fat, okay? And that's the reason why sugar can be fattening, because glycogen will be then converted into a fat. Okay, so lots and lots of sugar in the body will increase glycogen, which if you have a lot of glycogen will be converted into fat. Now, lastly, if you have high blood glucose levels, so high blood sugar, the beta cells are going to kick in and we're going to increase insulin. Insulin. Okay, and that's via the beta cells. Okay, so that word is insulin. All right, and so as we increase insulin, we increase glucose. Okay, we're going to store that as glucose. So what happens is that you have your high blood sugar levels, that increases your insulin levels, and then what that's going to do is cause you to change glucose into glycogen. Okay, so we're going to convert glucose into glycogen. So we want to decrease our glucose. Okay, so sorry to confuse you there. If you increase blood sugar, you increase your insulin via the beta cells of the pancreas. Okay, and then what you're going to do ultimately is you're going to lower your glucose because you're going to convert your glucose into glycogen. Now, just lastly here, last little point, where does all of this happen? The pancreas is in charge, definitely, okay, of making glucagon and making insulin, but this stuff happens in the liver. Whoops, sorry, hit my phone there. This happens in the liver. Okay, so I hope that these lessons have helped you. I know that I haven't been speaking as well as I should have been, okay? My brain's a little foggy. I don't know why. I think it's this weather. And so what I'm going to do with you guys is just leave you at this point with your diseases and deficiencies. You can read through them. You don't need me to read through that with you. You've got your lessons on the endocrine system. You can feel free to look at other videos, okay? I'm not going to give you any extra work. What you're going to find tomorrow is some review sheets, okay? So I'm going to give you some review sheets and just to test your knowledge. But your job is going to be to write an LMS quiz based on this information and just seeing where your knowledge level is at, and can you talk about antagonistic pairs, and if one level goes down, how does the other one go up, and can you diagnose a patient based on their deficiencies, okay? So that's what I'm going to be doing with you. So no extra work from the textbook. You can certainly read the textbook, but I'm not going to be using anything from the textbook in terms of the LMS quiz because I feel like you've got enough here with all these lessons.